All right. Hello. Good morning to all my WC students. Welcome back. All right, students. So we are left with 5 almost days for the final examination. So I'll be sending from today completely the term 2 syllabus, the final revision. Okay. So today is a part 1 of the particular topic. As you know, your term 2 syllabus, yes, it includes the chapters. What are the chapters which you have? In physical chemistry, you have electrochemistry to study, correct? After that, you have the next topic, that's nothing but chemical kinetics to study, correct? After the chemical kinetics, you have a chapter that's nothing but of your physical only, that's surface chemistry to study, correct? Done. So in this, after physical, we are gradually coming into an inorganic chapter, that is DNF block chapter. Perfect. After that, you have an organic chapter, that's nothing but aldehydes, ketones, and acids. After that, you have a chapter that's nothing but amines. And important, the most important chapter, that is coordination compounds, is one more chapter which you have. Correct. So I'll be doing in these 5 days, yes, the most that is your short questions of your term 2. Short questions, students. I'll be doing all the short questions. If you study these, I assure you, you'll get more than 95%. Let's start off with the session. All the best. WOC is always there with you all. Nothing to worry. So every day we'll be having these short questions, 5 day sessions. So 5 sessions I'll be picking up. So please watch the complete video, and my request is please remember, yes, already PDFs are sent in the Telegram. Join the Telegram for your notes. Okay, for the notes, Telegram channel link is pinned below. Now let's start with the first one. So this is your CBSE marking scheme. Yes, as I mentioned, you have 7 chapters. Remember, students, you have section A, section B, section C, correct? So the total number of marks are 35 and the total number of questions are 12. Marks is 35, questions are 12. Remember, in section A part, yes, you will be getting 1 2 marks questions from electrochemistry. Done. Aldehydes and ketones, you'll be getting 4 questions, students. Oh my god. And amines, nothing. So you should mostly concentrate for the 2 marks questions on the aldehydes and electrochemistry. Right. In section B, you'll be getting 3 marks questions again from electrochemistry. In chemical kinetics, nothing from 3 marks, and remaining all you'll be getting in 3 marks questions. So maximum students will be losing marks here. Careful. Okay, right? So this is a question. Careful, students. So basically what happens is your 3 marks question means don't get tensed. Write it perfectly in the theory. All right, students, nothing to worry. So after that comes your 5 marks question, which is nothing but a case-based question. Case-based. So in the case-based question, 1 into 5, 5 marks is the total. Done. So this is the question number which you have. This is the marks which you have. Marks are always mentioned in the bracket. So total is 1 case-based question which may come from chemical kinetics chapter. Done, students. And next important thing, total is 35. Remember, there is an internal choice which is given. In 3 marks question, internal choice would be given. And in 5 marks question, internal choice may be given in TD subpart. So there are 2 choices. One is in 3 marks question, choice would be there, and in the 5 marks question, choice would be there. Got it, students? So please check that. So today we are going to start with the most important. I'll be picking up organic chemistry. Yes, in organic chemistry, learn the students, this will compulsory come. In organic chemistry, I'll be picking up 2 marks questions and 3 marks questions. Okay, done. So now basically tell me, organic chemistry, what topics you have to study. Compulsory identification based questions will come in organic. Okay, students, identification based questions compulsory would come in organic. Questions is compulsory, you'll be getting for 3 marks. After that, conversions you're going to get compulsory in organic chemistry. After that would be your named reactions which would come compulsory. They're going to ask you named reactions. And important distinguishing tests. So distinguishing tests are going to come. So I'm going to revise all those, nothing to worry. Okay, students? Yes. So in organic chemistry, they're going to give you paragraph based question. Means they will give you a paragraph and they are supposed to answer the based questions. Paragraph questions would come where you are supposed to answer the paragraph questions. So let us start off. Today I'll be covering almost everything. We will see, and I'll be uploading the videos for 5 days. So all would be short questions. Okay, students, short questions would be there all the 5 days. So go through the short questions. Done. Let's start off. So today we are going to start, as mentioned, organic chemistry 2 marks and 3 marks questions. So for the first question, let us see this question. Very important. Which reaction is this? This is an identification based question. Correct? Now, what is this? It is an identification based question. Correct? Now, done. Now, check, students. So basically, in this identification based question, first, as soon as such question is given to you, remember, try to know or write the name of the reaction. What is this reaction? It is nothing but Rosenmund reduction. Correct? Na? Rosenmund reduction. Okay. Now, what is this reaction with hydroxyl, or if I say hydroxylamine? It's nothing but nucleophilic addition reactions. Correct? Where you remain water molecule. Right? Okay. Chalo. Now, let us understand. So, once you write this, start writing the reaction in the exam. Let us first understand. So basically the first reactant is acetyl chloride. Done. In Rosenmund reduction you have hydrogen in the presence of palladium and barium sulfate. Done. So what will you do? You will subtract HCl from this. HCl from this. So what is going to happen? Your hydrogen goes and adds to this and you get a compound nothing but aldehyde. So once you get your acetyl or ethanol rather, name this compound as A. That is nothing but ethanol compound. Done. Now what are you doing to this ethanol? You are going to introduce hydroxylamine, NH2NOH rather. It is like this. So what will happen? This hydrogen and this oxygen is lost and you will be getting a compound. Just join both of them. You will be getting CH3 is here, CH is here, and your double bond, because nitrogen total number of bonds are 3, nitrogen and OH. What is the name of this compound? This is compound B. That is nothing but ethanol oxime. Ethanol oxime. Oxime means your compound NO. That is your ethanol oxime. So careful, compound A and compound B. So basically, so what should you do before we start the next question, students? So careful. So you will write the conclusion of the particular this one given is named right like this. Write like this. A is nothing but ethanol. Ethanol. So write like this, CH3CHO. Okay. What is B? B is nothing but ethanol oxime. Ethanol oxime. Write like that, ethanol oxime. And you're going to write the formula CH3CH double bond NOH. So done. So this is nothing but your 2 marks question, students. This is 2 marks question. Okay. Right. Now let us see one more question. Very important. Yes. Okay, this is again one more identification based question. Very important identification based question. So identification based. Now in identification based compulsory, this is a 3 marks question. Right, let us see this. Right, so write the structures of A, B, C, D and E in the following reactions. Now what is this compound? This is benzene. What is this particular thing? This is nothing but anhydrous AlCl3 and acetyl chloride. When you see, remember, it is nothing but Friedel-Crafts acylation reaction. Correct, na? Friedel-Crafts acylation or acetylation reaction. Acylation or acetylation reaction. Okay, it's giving a compound. After that, zinc amalgam in the presence of concentrated HCl. What is this, students? It is nothing but, you have 2 things. One is Wolff-Kishner reduction and one is Clemmensen reduction. So it's nothing but Clemmensen's reduction. Clemmensen's reduction. Done. After this, yes, KMnO4 and KOH. What is this type of reaction? This is nothing but oxidation reaction. Okay. NaOI, what is this reaction? It is iodoform reaction. Correct? So you will write. So type of reaction, write it like this in the exam. Type of reaction. First important thing, first type of reaction is what? It is Friedel-Crafts acylation reaction. Okay, done. After that, second is Clemmensen's reduction. Okay, done. Third type is oxidation reaction. Fourth type is iodoform reaction. Correct, na students? Done. Write like this. Now write the things, write the formulas and finish off things. So first of all, what is given? It is benzene is given to you. Done. So to this benzene, what are you writing? You're treating it with acetyl chloride with a particular loose acid anhydrous AlCl3. Done. Break this. The chlorine is taken up with the Lewis acid and your acetyl group goes and attacks your benzene ring. So what do you get? You'll be getting this compound. Correct? Okay, done. So this is your compound A. Finish. After that, you're treating this compound with zinc amalgam and concentrated HCl. Remember this. So what will happen? Whatever, irrespective of the size, whatever it is going to get converted to your alkanes. So your oxygen is lost and hydrogen is added. So you will be getting a compound that is nothing but your side chain halogen, side chain alkylation. So you'll be getting an alkane. This is your compound B. After this, you're treating this with potassium permanganate and your KOH and you're heating it. So what is happening, students? This is basically which one? It is an oxidation reaction because it is an oxidizing agent. So irrespective of the size of the alkyl chain, you will be getting which compound? Acid, benzoic acid. So this is compound C. Now, what did they say? They said compound A. If I see the question, they said compound A is taken and used for iodoform. So I'm going to take compound A. So this part is A part. The second part is B part. Now compound A, what did I take? This is a aromatic ketone, aromatic methyl ketone. Done. So because this is a methyl ketone group, it is compulsory showing iodoform reaction NaOI. Correct? So this is iodoform. What will happen, students? One, you will be getting a sodium salt. Correct? And what is the other one? This is compound E. And final thing, you will be getting iodoform, yellow color precipitate of iodoform. This is compound D. This is LOPPT, which is nothing but iodoform. Perfect? Yes. So these are your reactions. So once before you start, before finishing of the answer, you are going to write a conclusion because you are going to get mark here only. So what is compound A? This is your compound A. Done, students? Take this compound A. What is compound B? Compound B is nothing but your alkane. Okay, aromatic. Okay, compound C is nothing but benzoic acid. This is also done. Compound D is nothing but your iodoform. Compound E is nothing but your COON. That's all. That's all. Here you will be getting marks. The examiner is going to give you marks here. Clear, students? Okay. Let us go to the next question and see. Name reactions, I said now. It's a 2 marks question. So check. They've asked you Hoffman's bromamide degradation and carbylamine reaction. Right? So simple. So what to remember? Let me take with the next page. This is for Hoffman's. This is for carbylamine. Okay. I write here both. So first of all, Hoffman's bromamide degradation. What is it? So in the exam, you very well know. Because like if you don't remember or if you just can't write the complete reaction, you can stop, just write the thing like this, put the heading. Suppose complete you don't know, just remember, students, Hoffman's bromamide is used to convert amides to amines. Which amines? Primary amines. So right, what you require, you basically require sodium hydroxide and in the presence of bromine. So what is important here? This is nothing but degradation reaction, means you will be getting one carbon less product. One carbon less product is what you're going to get. Suppose in the exam, if you don't know, remember this. If you write, you will get 1 mark. So check the reaction. It's basically amide. Correct. Now this amide, this R group can be what? It can be alkyl group. It can be aryl group also. R can be alkyl. You can, if you put AR, it will become aryl group. Done. What are you doing? You're adding bromine. You're adding sodium hydroxide, a base. So how many moles? 4 moles. So you will be getting 4 important products rather in this. Remember, first is, this is one, here 2 carbons are there. Now you'll be getting 1 carbon less. That is amine. Done. After that, NABR 4 are there now. So 2 will come out as Na2. So 2 will come out as NABR. Yes, one more will come out as sodium carbonate. Now see, 2 plus 2, 4 are over, and 2 water molecules. So this is your Hoffman's bromide degradation. Next, what is the next question? They asked me carbylamine reaction. Can I write carbylamine here? Yes, I will write carbylamine here. So carbylamine reaction is nothing but you're going to convert, simple thing, nothing, converting primary amines to isocyanides. Primary amines to isocyanides is your carbylamine reaction. So take the reaction. So RNH2 in the presence of chloroform. Don't get confused, students. Don't write methyl chloride here. In the presence of a strong base, and when you heat it, you'll be getting isocyanides plus KCl plus water molecule. Correct. So if you take 3 moles of this, it will be 3 and 3. This is your carbylamine reaction. Easy, simple. So even if you write this one, you will be getting here with the reagents. If you get, you will be getting 1 mark for this. Perfect. Next question. Let us see the next question, students. Oh, nice. Identify A to E. You have to identify A, you have to identify B, you have to identify C part. This is your C part. You have to identify D, you have to identify E. As soon as the reaction is given to you, remember, write the type of reaction. Okay. The first type of reaction is nitration reaction, addition of NO2 plus group. Second type is nucleophilic substitution reaction, where you will be adding chlorine nucleophile to this. Third type is reduction reaction, where you will be adding hydrogen or removing oxygen. Fourth type is nothing but Rosenmund reduction. Okay, so let us start writing the reaction. And first, you're taking benzoic acid. Correct, na students? You're taking benzoic acid. To that, what are you treating? Nitrating mixture, that is concentrated nitric acid and concentrated sulfuric acid. So what is the electrophile here? NO2 plus is electrophile. So NO2 is which directing? It is meta directing group. So it will go and attack the benzene ring at the meta position COOH and NO. Yes, this is your compound A. Now what are you doing? You're treating it with thionyl chloride. See this, thionyl chloride. Now thionyl chloride, yes, this is the nucleophile, this is the nucleophile. The chlorine goes and replaces that, and you'll be getting a compound that is nothing but Cl and N. This is compound B. Now what are you doing? You're treating this with reducing agent sodium borohydride. That is nothing but your reduction process in the presence of hydronium ion. So what will happen, students? Reduction means, check here, you're taking out this particular hydrogen. Okay, sorry, chlorine. You're taking out this chlorine, and you'll be adding 1 hydrogen here, and you'll be adding 1 more hydrogen here. So what compound you'll be getting, students? You will be getting a primary alcohol. Remember, CH2OH, a primary alcohol with meta directing nitrogen. This is your compound C. Now you're taking this compound, see, till here it is over. What did they give me? Yahan tak ho gaya na, this is one part. Now, second part is again take benzoic acid. So let me take this is not there. Okay, now I'm taking again benzoic acid. So do I have a second page? Yes. Now I'm going to take benzoic acid, perfect, and I'm going to treat it with again thionyl chloride, SOCl2, the same thing which they gave me. Again, what am I doing? I'm replacing OH with chlorine, so I'll be getting a compound which is benzoyl chloride. This is D. Now what did I do? I've treated this with palladium, barium sulfate, and that is nothing but Rosenmund reduction, and you're poisoning it with quinoline. Quinoline is used to poison the thing. Now, so that the reaction stops there. What will I get? Benzoyl chloride will get converted to benzaldehyde. It is benzaldehyde. This is compound. Easy, students, easy. So basically, before we go to the next question, please remember, whenever you do identification questions, write what is A, write what is B, what is C, what is D, what is E. If you write like this, examiner will put a tick like this and give you mark here only. Okay, students, got it? Sure. Now let us see one more question. Yes. So amino group is in aniline is orthopara directing group, directing in aromatic electrophilic substitution reactions. Aniline on nitration gives substantial amount of meta-nitroaniline. Why? Okay, once again read. Amine group is, amino group in aniline is OP directing group. Okay. In which one? In aromatic electrophilic substitution reactions. Okay, done. So first of all, they are saying aniline is OP directing. Okay, right? In aromatic electrophilic substitution, whenever an electrophile comes, it is OP directing. Why? Okay. But when you do nitration, you'll be getting meta-nitroaniline 1. Check, students. First of all, aniline is when it is protonated. What are you getting? You will be getting anilinium ion. Yes. So this anilinium ion is what is nothing but electron withdrawing. Yes. So remember, students, check, and that too anilinium ion is meta directing. 2 points you're writing. First point. What happens here during electrophilic aromatic substitution? Aniline is protonated. When aniline is protonated, what will happen? It will form anilinium cation. Okay, now this is a positive ion, correct? So anilinium cation is positive. So what will it do? This anilinium cation is going to drag the electrons by inductive effect. So this anilinium cation is what? It is meta-directing. So when nitro group comes and attaches, nitro goes and adds at meta position. Easy? Cha. Easy question. Next question, let us write. Aniline does not form Friedel-Crafts reaction. What is the reason? Simple, students. Now, this is a Lewis acid. Correct? This is a Lewis acid. Now, what happens? Now, this aniline is basic. Obviously, this is base. This is acid. So, acid plus base. So, this is an acid which will combine together. So, what will happen? Acid is a Lewis acid, combines with the base, that is aniline, and it forms a salt. So this is nothing but a salt. This is called adduct. So aniline being basic, remember students how to write this. Aniline is basic. Correct. Second point, it forms adduct means addition product. Adduct with which one? With AlCl3. Okay. When it forms adduct, what does it form? It forms salt. Perfect. When it forms salt, what will happen? Automatically, when already the salt formation is there, so an electrophile cannot be generated na? When you are trying to add Friedel-Crafts reaction like acylation or alkylation. Suppose if I take Friedel-Crafts alkylation reaction. So what is the electrophile in this? CH3 plus. In acylation reaction, what is the electrophile in this? Friedel-Crafts acylation, it is CH3COCl. Okay, that is CH3CO. So where will it go and attack? Already salt is formed. So alkylation, acylation will not happen because already salt formation is done. Correct? Salt formation is already done. That's why it will not further react. Okay, done. Easy. Next question, let us see. It's a paragraph based question. It is a 3 marks question, students. 3 marks. Very, very important. Check. A compound A has having a molecular formula C3H7ON. Okay. It reacts with bromine in the presence of sodium hydroxide. Done. When something is reacting with bromine and sodium hydroxide means the compound should be an amide. Done. And it gives compound B. Now this B reacts with HONO. Okay, HONO. HONO is used to differentiate primary, secondary and tertiary alcohols. Correct na? So HONO. So it gives compound. It forms an alcohol. This is okay, an alcohol. And what is this? Now this is compound A. This is compound B. Alcohol plus nitrogen gas. Identify the reactions involved. Simple. See this formula. C3H7ON. This is what, students? Amide. 1, 2, 3 and 4. This is compound A. Then bromine in the presence of NaOH. So what will happen? 1 carbon less compound you will get. Done. So make the 3 carbons, 1 carbon less compound is this. This is compound B. Now you're going to add hono or nitric acid. Nitrous acid is used to differentiate between primary, secondary, and tertiary, where primary forms alcohols, and along with this nitrogen gas and hydrogen gas. That's all. So the compound A is amide, compound B is primary amine. Got it, students? So you're going to write that in the exam. Done. Easy. Next question. Write the structures of organic. This is a 2 marks question. Carefully do it. So what is A, B? Easy. Now check, students. This is which one? This is Hoffman's bromide. So 1 carbon less compound I get. What is this? This is used to differentiate primary, secondary, tertiary. Oh no, nitrous acid. Done. Okay, then what is this? This is nothing but your, in the presence of chlorine and metal, rather. Chlorine and metal. So metal means, so what will happen here? You will be adding the chlorine part. That we will see what it is. Whether it is Sandmeyer's reaction, whether it is going to BDC, what it is, we will check. Done? Sure. I have a place. Okay, now let me say first thing. First is sodium hydroxide and bromine. So automatically what do? I take an amide. Amide. How did I decide this? Because when you see this particular reaction, already you're getting an amine. So this amine you are getting from where? From the amide. So even the starting material also should be amide, but with 1 carbon in that. So let us go back and write, this is nothing but your amide. This is your amide reaction, amide. Done. So this is A. After this, what happened? You have treated with the sodium hydroxide, it will become 1 carbon less. So it is amine, aniline. This is B. B, you're treating it with NaNO2 by HCl 0 to 5 degrees centigrade. 5 degrees centigrade. Aniline gets converted to BDC, N2Cl. This is C. Correct. Now what are you doing? You're treating it with D. What is that? And it is giving me a compound. Yes. Treating with D and it's giving me a compound E, they said. So here I don't know anything. What is it? They gave me one clue here. E, yes, you're treating with chlorine in the presence of iron, they said. It is giving me F, they said. F, you're treating with hydrogen and platinum, they said. Now this is reduction. So go back. Go back. So here compulsory the F product, whatever you're getting. Yes, students. So check here carefully. F product, there should be an hydrogen atom. And C product, it should be a cyano, or basically a compound which is having a cyanide group. So that means your C compound compulsory after BDC, it should be KCN and Cu. Why? E part is your cyanobenzene. Okay. Now, after E part, there is F part. Yes, you only check. This F part is already the given part. This is your F part. Whatever they gave now, this is the compound which is given as C2H, CH2F, NH2. Why? Because they have mentioned in the question there. Now what will I do? This particular reagent, no, not like that. So what did they give? They gave that from here they gave the connectivity. From here they gave the connectivity. So see the students, this group when you break, you'll have 2 hydrogens here, 2 hydrogens here. So it become primary amine. That means your E is getting converted to your F part. So E is getting converted to this molecule which is given. Now F part is left. Now you only tell me cyano group on chlorination. What is this F part? Guess it. Guess. Please mention your comments mention your answer in the comment section. I'll be seeing who is going to answer it. What is F part? So basically I have got A, B, C. Okay, A, B, C, and D also I got. This is D. This is E. Okay. Yes. So you're going to mention that in the comment section about what is F. So I got A, I got B, I got C, I got D as a reagent, I got I got, all right, D also I got E also, I got given product last one. So please find out what is F. Clear, students? Done? Inshallah. This is for the homework. Tell me in the comment section. Next question. How do you account for the following? Aldehydes are more reactive than ketones towards nucleophiles. Okay, this is a 1 mark question. This is a 1 mark question. Simple. They're asking you, aldehydes are more reactive than ketones. Let us see whether we have placed. Yes, this is one first question. Let's see. Aldehydes are more reactive than ketones towards nucleophiles. Now see, student, what is a nucleophile? Nucleophile is an electron-rich, yes, it is electron-rich reagent. Done. So it will go and attack sites which is electron deficient. Okay, correct. Now it will go and attack sites which is electron deficient and donate electrons. Now check here. In case of aldehydes, you have R. There is only one alkyl group. So oxygen is going to pull the electron density. This will become positive carbonyl group and this is negative group. If I take ketones, yes, this is your group. Yes. Alkyl group donates, this alkyl group donates, this becomes negative, this becomes positive. But better, na? Already this is plus I group which is donating. This is plus I group which is donating. So when both are donating, automatically your alkyl protonated or not protonated rather, carbonyl carbon, whatever is there, has better electrons, correct? Na? So this carbonyl carbon, what is there? This carbonyl carbon positive charge is satisfied by two R groups, correct? Na? Two R groups will go and satisfy positive charge. Positive charge. Done now, students? Now, but in this case, what will happen? Check carefully. Your carbonyl carbon, there is only one R group, correct? So what will happen? Nucleophile will come and supply its electrons to carbonyl carbon. Okay, students, done. So the nucleophile attack, yes. So here what will happen? The positive charge means lot of electrons required. More positive charge. More positive charge. So automatically nucleophiles will come and attack this aldehydes, not ketones. Easy? That's all. So write down, simple to write the summary. In aldehydes, positive charge on carbonyl carbon is more because of one R group. Nucleophile comes and attacks this. Easy? Next question. The aldehydes and ketones undergo a number of addition reactions. Why? Yes. So let's first list out the addition reactions. Addition reactions of aldehydes include addition of HCl, addition of NaHSO3, addition of alcohols, addition of ammonia derivatives, correct? Addition of Grignard's reagent RMGX, correct? Now you need to tell me why it is undergoing so many addition reactions. Yes, we very well know aldehydes and ketones, they possess carbonyl functional group, correct? Yes. So with number of nucleophiles, now this is a nucleophile, this is also 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 a nucleophile, this is also. So what happens, whether it is your aldehyde or your ketones, whatever both are they, these will have a carbonyl carbon. Because of this carbonyl carbon, the nucleophiles will come and attack the carbon. Yes, students? So the nucleophiles will come and easily attack and supply electrons to this. So that's the reason you will have more of nucleophilic, more of addition reactions. So these are all nucleophiles. Done, students? Done. Easy? Next question. Oh, big question. An aromatic compound A of molecular formula C7H7ON undergoes series of reactions shown below. Write the structures. Almost similar. See this. This is Hoffman's. Correct. This is Hono. Done. Primary alcohols. Done. This is which reaction? This is chloroform. That's nothing but your carbylamine reaction. Carbylamine reaction. Done. So potassium iodide is nucleophilic substitution reactions. Easy. And this one, it is nothing but your alcohol. Alcohol, what will it do, students? It will remove the electronegative atom and it will form benzene. Yes, it will add the hydrogen to the benzene ring. Reduction. It will help in reduction and it will. Let us do the reaction. Chalo, first take. First compound, what did they give me? C7H7ON. Write it like this. C7H7ON. So this is compulsory amide. Okay, done. I have taken one amide. NH2. C6 plus 1, 7. This is A. Now we are introducing with bromine and KOH. One carbon less compound you get. That's nothing but your amine. Done. To this compound, what are you doing? You're introducing NaNO2 plus HCl. That is HONO at 273 Kelvin. What will happen? Aniline gets converted to BDC. BDC. So this is your compound B. Now B, you're treating with reducing agent alcohol, which is nothing but it is going to eliminate nitrogen gas. It will eliminate HCl gas and add one hydrogen and you will be getting benzene. This is compound C. Now, aniline you're treating with chloroform and sodium hydroxide. That's nothing but carbylamine reaction. So this is compound. This is D. Now, B, what did they say? Your BDCB, you're treating it with potassium iodide. It's a nucleophile, so you're getting iodoalkane, I. This is compound E. Got it? Yes, students. So once you do like this, please try to write in the exam. What are what. So what is compound A? It is nothing but benzamide. What is compound B? Compound B is nothing but BDC. What is compound C? It is nothing but benzene. What is compound D? It is nothing but isocyanide. NC. Yes, did we write NC? Yes. What is compound E? It is nothing but iodoalkane. Write like this. So that the examiner will put a tick here only like this. What is, students? Yes. Let us see one more question. Oh, big question. It's a compulsory 3 marks question. Remember. Okay. Compound B gives positive iodoform test. Okay. So compulsory, and let us read. It means it contains methyl ketone group. Okay. It is a ketone. Done. Moreover, B, that means I understood B is a methyl ketone. Moreover, B is obtained by oxidation of A. Okay. Done. So which will give ketones, students? Compulsory secondary alcohol should be give ketones. See this, they have written. Okay. As only secondary alcohol gives ketones on oxidation with copper at 573 degree Kelvin. Hence the structure. Okay. So basically they have given us certain clues. They have given us certain clues. So with these clues, I'm going to make one. Let's start. So clues, I made it in the form of an answer. Let's see. First. So they said compound B is going to be, or it will have, shows iodoform test. So B shows iodoform test means B will be ketone. Okay, that is your acetone. This is B. Done. This is your acetone molecule. This is B. They said acetone is obtained from alcohol. Which alcohol? Secondary alcohol is what it forms. Secondary alcohol. Done. So it is nothing but A. Now they said acetone molecule is a ketone with Fehling solution. Fehling solution, it doesn't show any reaction. But this is a methyl ketone. The methyl ketone is going to react with iodoform and it is going to form, what is it? Iodoform, the yellow color precipitate of iodoform is formed. 3NaI always. This will be 4 molecules, this will be 3 molecules, and iodoform CHI3 would be formed as a white yellow color precipitate, and this is water. So see the clues. They gave us a clue here They gave us one more clue here. They gave us one more clue here. So I've written all the reactions here. Done. So what is important? Reading the question is important. Done, students. So finally, I will summarize. A molecule is nothing but my secondary alcohol, because secondary alcohols on reduction gives ketones. So even if not reduction, rather if I have to tell you, secondary alcohols, okay, removal of no, oxidation. Students, copper here is acting as an oxidizing agent, because you're removing two hydrogens from here. See here, you're removing one more hydrogen, one more hydrogen. Yes, you're taking out, that means you're taking out hydrogens and adding, taking out hydrogens, nothing but oxidation process. Done. Sure. So what is your B part? B part is acid. What is C part? C part is iodoform. Done. So all the three perfectly done. Next question. Oh, easy. So what do they give me? Write the structures. This is again a 2 marks question. Write the structures of A, B, C in the following reactions. Now see, what is this? This is reducing agent. This is HONO, used to differentiate primary, secondary. This is hydrolysis process which you are doing. Okay. This is again nucleophilic substitution reaction. This is reducing agent. This is again used to differentiate primary, secondary and tertiary. Done. Amines. So let us take first one. C6H5NO2 with your reducing agent. What will it give me? Oxygen gone, hydrogen added. So you get aniline. So this is a primary amine, correct? Yes. So primary amine with HONO, that is your nitrous acid at 273 Kelvin, will give me what? BDC. This is compound B. This is compound A. BDC you're treating. Do I have one more page? I don't have. I'll write a little bit smaller. BDC with water, what do? Yes, you heat, nitrogen gases out, HCl is out. What is left out? One hydrogen is added. You will be getting C6H5OH. Phenol molecule you get. Correct? So this is your compound C. This is reaction 1. Second reaction, what did they give me? They gave me methyl chloride. Okay, let me write. Methyl chloride. When I substitute with KCN, what will happen? Cyano compound is replaced with Cl. I'll be getting methyl cyanide. This is A. Now you're adding lithium aluminum hydride, which is a reducing agent. Break this bond, add two hydrogens here, two hydrogens here. You'll be getting methyl cyanide. This is B. So, sorry, primary amine B. B you're treating with HONO. Yes, 273 Kelvin. You'll be getting alcohols. You'll be getting primary alcohols. Done. Easy. Easy. Yes. Yes. So, very important question. It's a 2 marks question. Now, understood, students? Next question. Write simple chemical test to distinguish between. Okay, distinguishing test. Yes, distinguishing tests are again for 2 marks. Now, observe carefully, students. Yes, done. This is what? This is a ketone. Correct? This is also a ketone. Then how to differentiate? Yes, remember. So, ketones are specific to give iodoform test. Correct? Now, observe carefully. Yes. First one, I will take pentan 2-one, and this is pentan 3-one. Write like this. So, write the structure. This is my pentan 2-one. Done. Write this compound. This is pentan 3-one. Okay. Now, in this molecule, to give iodoform, what is the condition? It should have methyl ketone. Correct. Now, observe. In this, when I check, here also it is ethyl, here also it is ethyl. Will it give iodoform test? No reaction. It should have a compound something like this, It should have a compound, it should have a methyl ketone, something like this. Then I will give iodoform. It will give iodoform. Now check this. Yes. You have a methyl ketone here. It gives iodoform test. Right? Easy. Next question. Ethanol and propanol. Same, you can take either form. Check, students. Ethanol. Ethanol has CH3C double bond OH. Yes. This is a methyl ketone, so it gives iodoform test. Second one, propanol. CH3, CH2, CHO. There is no methyl group here. It is CH2. So iodoform it will not. So this will not give, this will give, this will give. So done. Differentiation is done. Okay, so like that you have to do, students. One more question important. So check carefully, what should I remember? So for iodoform reaction, you should always have methyl ketone. You should have acetaldehyde group. It is like this. Yes, it will, like these molecules are going to show the iodoform test, positive iodoform test. Done. Next question. Convert benzaldehyde to acetophenone. Oh, easy. Okay, malonic acid to acetic acid, acetaldehyde to 2-butanol. So let us start. I have how many pages? 1 page, 2 page, and 3 pages. Okay, I have 3 pages. I will take 3 pages to do it. First one, benzaldehyde to acetophenone. Let me take. Okay, to acetophenone. Acetophenone. Check. This is my benzaldehyde. Okay, done. I have to convert it into acetophenone. This is the molecule done. Correct. Observe carefully. Observe carefully. First thing, always remember, aldehyde, you do oxidation process. If you do oxidation process, what will happen? Aldehydes on oxidation gives me acids. This is easy. Done. Acid, try to use a sodium hydroxide. Why I'm saying? Because once it gets converted to your sodium benzoate, it is easy for me to take out carbon dioxide from this. So I will use soda lime. Done. And heat it. When you heat it, your carbon dioxide gas escapes out, and I'll be getting sodium carbonate also escapes out. You'll be getting benzene. Now benzene is ready. What do? You do Friedel-Crafts reaction, Friedel-Crafts acylation reaction. AlCl3 with CH3COCl. That's all. Acetyl group is added and your HCl is added. That's all. Easy. So easiest procedure to do, convert benzaldehyde to acetophenone. Please check that. Next, what is the thing, students? They said malonic acid to acetic acid. Malonic acid to acetic acid. Check. What is malonic acid? This is malonic acid. Malonic acid. So malonic acid to, when you heat it, what happens, First important thing, check your carbon dioxide gas, what is there, escapes out. The left out molecule is nothing but acetic acid. That's all. Last one, what did they give us? They have given us the last conversion, acetaldehyde to 2-butanol. 2-butanol. All. Yes, easy. Aldehyde to alcohol. Now students, remember, first always remember, aldehyde to alcohol is done in aldol condensation reaction, this one, which is easy. Once you do that, and finally you can convert it to primary alcohol. Let us see how we will do. Take 2 molecules of your aldehyde. Done. Oxygen shifts. Alpha hydrogen from here goes and shifts. And what do you get? This happens in the presence of a base and heat. What do you get? You get a compound that is nothing but CH. Careful. And to this CH you're going to make OH. Done. And CH and one more H and your CH2. This is nothing but aldol, correct? Aldol, what do? You're going to further heat this. When you heat it, your water molecule eliminates. From where? And you shift the bond. what do you get? You'll be getting a compound that is nothing but, yes, but-2-enol. Correct. Now what you do, you're going to use a reducing agent like sodium borohydride, reducing agent. So reducing agent, yes. So here, important thing. So here, reducing agent, what does it do? It is going to add hydrogen. So it will add one hydrogen here. It will add one more hydrogen here. What will I get? I'll get a molecule that is nothing but butane. So this is 2-butanol. Okay, that's so acetaldehyde to 2-butanol. This is a perfect method to do. Try to use aldol. After aldol, try to use reduction. Okay, yes. Next question, very important question. Remember, write the order of increasing, write in decreasing order of the pKb values. Okay, done. Now remember students, whenever pKb question is given to you, remember smaller pKb value, stronger base. This is the clue for this. Second, in the same way, remember the one which is having more I plus I groups. Okay, once again I'm repeating, the one which is having more plus I groups, whether it will release electrons or not, let's see and understand. Second, basic strength. Once again, same story, careful. Decreasing order they asked you to write. Yes, yes. So what is important? More plus I groups, more basicity. Decreasing order of the basic strength, same concept. So let us write. In case 1, first question, series. Now here, what should you remember students? They asked me to arrange in decreasing order. Okay, sabse kam wala last. Right. So kam wala last and the most easy release one is first. So C2H5 is NH2. So pKb value, remember students, careful, this is a decreasing order of pKb. So the one which has small pKb, means it should have more number of alkyl groups. Yes, this one which is stronger base. So the order goes like this. This is the order according to this. Next question, increasing order of the basic strength. Aniline. Okay, so first para-nitroaniline, because this is electron withdrawing group, basicity is less. Then comes aniline. Then comes para-toluidine. What is para-toluidine? Para is CH3. This is your toluidine. Correct, students? Yes. Now, next one. C6H5NH2. Okay. Decreasing order of the basic strength. Sabse kam wala. So, in this benzene ring, this is electron withdrawing group. Sabse kam. After that, there are two groups. Sabse kam. After this, there is, okay, methylamine kam. Sabse zyada is two alkyl groups. This is more because more electron, more plus I groups, more basicity because it will donate electrons, na? Yes, this is electron withdrawing group, so less basic in nature. Correct, my students? It is less basic in nature. Done, done, done. Now, check, perfect. So this is up. So finally, yes, we have completed short questions in organic chemistry. Yes, so please go through. I will come back with one more video tomorrow. My request, subscribe to the channel, like the channel, share the channel and comment. Yes, tomorrow day 2 session would be there where I'll be sending one more, that is nothing but your important questions or the short questions of DNF block. Okay students, please join it. Thank you so much for watching. Thank you.